Hi, welcome back. Welcome to our lecture series on software design pattern. Today, we are delving into one of the most crucial pattern in software architecture, the observer pattern. This pattern is a key player in creating dynamic interactive system. Let's explore why every aspiring software architect and developer should understand it. Why learning the observer pattern is very important. In the rapidly changing world of software development, system needs to adapt quickly to changes. The observer pattern is essential for scenarios like user interface, where elements must update in response to user interaction or system changes. It is about creating a responsive, interacting environment. Understanding the observer pattern at its core. The observer pattern is a behavioral design pattern that forms a one-to-many dependency between objects. It allows an object known as the subject to notify other objects known as observers, so subject and observers, of state changes. This notification mechanism is key to maintaining consistency across different parts of the application while avoiding tight coupling between them. The core components are subject, an interface that maintains a list of observers and provide mechanism to add, remove, and notify them. The concrete subject implements the subject interface and maintains the state, notifies observer when changes occurs. Observer, an interface with a method to update observers. And the concrete observer implements the observer interface and updates itself in response to notification from the subject. All right, so look at this C++ code implements the observer design pattern. A software design pattern that defines a one-to-many dependency between objects. When the concrete subject state changes, all its subscribers, which is the concrete observer instances, are notified and updated automatically. Concrete subject maintains a list of its observers and provides methods to add, like add or remove, or you can say that attach or detach them. Okay. So concrete observer registered itself with a subject to receive updates. The main function demonstrates the pattern by changing the subject state, which triggers notification to its observer, updating their state and outputting the changes. Cleanup is performed at the end of the prevent memory leaks. One or two important points here to note that this implementation is actually a push-based implementation. But there is another way, which is the pull-based implementation, that is also possible here. Okay, so let's discuss the pull model now. In this pull model implementation, when notify is called on the concrete subject, it no longer passes the state to the observers. Instead, observers call get state on the concrete subject to retrieve the current state when they are notified of a change. This allows observer to pull the latest information from the subject themselves. This pull approach is very useful when the state is complex and observers only need part of the data. The subject may undergo several state changes, but the observer only needs the latest change state at the certain point in time. So in that case, you want to reduce the amount of unnecessary data transfer when the state changes. That's why in some circumstances in your project scope, if such scenario appears or such scenario exists, then pull model is very useful for you. So I hope by now you are clear that there are two model possible. One is push model and another is pull model. And your job is to select appropriate option as per your project scope and requirement. Thank you. Thank you. Thank you for completing this video. And I hope that you definitely have learned something which will help you in your system design interview. Hope to see you in next video with new concept and skills needed for the system design interview. By then, keep learning, keep improving, and keep sharing your knowledge.